We are Lowton Science. We would like to introduce our developed technology, the Refined Texture Profile Analysis. Texture Profile Analysis, or TPA, has been extensively used for determining the textural properties of foods. Traditional TPA is conducted by 2 consecutive compressions to determine the textural properties such as hardness, fracturability, stringiness, cohesiveness, and chewiness. According to the procedural of conventional TPA protocol, the food should exhibit a certain level of springiness so that the springiness can be determined through the deformation test using TPA protocol. This is a non-destructive analysis. However, for the extent of tastiness, a destructive analysis should be involved to understand the internal textural characteristics of foods. Therefore, it is important that we assess the springiness of foods by non-destructive deformation tests, while getting information regarding the sense or oral taste by using the same set of analyses. Here we develop a protocol which we call Refined TPA to conduct both non-destructive and destructive analysis through new fixtures and adjustable testing conditions using programmed modulus. Here we develop a protocol called Refined TPA to conduct both non-destructive and destructive analysis through a new fixture and adjustable testing conditions using programmed modulus. In our Refined TPA, we can customize the analytical modulus depending upon the objectives of our analysis. We do this by combining various individual models such as compression, penetration, tension, and shear. For example, we do this with our modulus using a compression twice, tension twice, and compression plus penetration analysis. We could also conduct simultaneous non-destructive and destructive tests. We can also even provide rapid and easy tests of more than 2 models. This is an example for the modulus of tension twice for both non-destructive and destructive analysis. By using this modulus, we can easily analyze the textural properties of a noodle. The first stage of this modulus is to determine the extent of the deformation by the upward tension test, and then back to the original position. This stage is a non-destructive test. For the second stage, the upward tension is applied again until the noodle breaks. At this stage, this is a destructive tension. We can obtain a force time curve as shown above. By the first non-destructive tension test, we determine properties such as hardness and springiness. The springiness is calculated by the compressed energy over the restored energy. By the second destructive tension test, we can determine the oral related characteristics such as rupture force and tension. Here is a second example of the modulus for the compression and penetration. We can determine the textural properties of a shrimp. Similar to the previous example, the first stage is a non-destructive compression with a 20 to 30% depth of penetration of the sample. By doing so, we can determine properties such as hardness and springiness. For the second stage, we apply a destructive penetration to a depth of 90 to 95% of the sample, and thus we can get properties such as resilience, internal average, hardness, and compactness. We can also obtain a force time curve as shown above. By the first non-destructive stage, we can determine, for example, the hardness from the compression force as well as the springiness. By the second destructive stage, we can determine the characteristics such as fracturability, tension, average chewiness, and compactness. Additionally, we can in situ change the probes during our analysis to provide flexible and rapid testing. In traditional TPA, this can only be done by 2 separated analyses. Our Refined TPA offers an alternative solution, where we can use only one set of modulus for conducting 2 different types of probes. We program the time of switching of the different probes with a highly accurate calibration. This modulus is similar to the previous example, which has both non-destructive and destructive analysis. For a non-destructive test, we will use bigger probes with a cylindrical shape or disc shape. For the destructive tests, we can use smaller probes with either a cylindrical or a needle shape. Here are the examples with in situ changeable probes. Simply speaking, we can combine 2 different approaches of analysis into one single, rapid, and convenient modulus. The aforementioned modulus with pre-programmed TA sequence and macro are editable. All the modulus have a function of auto-reminder to ensure the accuracy and precision of the calibrations. The modulus also provides visualized interfaces to customize different analytical stages. Furthermore, we can use magnetic adapters to avoid the damage of probes during different switching stages, as well as saving on the overall time of analysis. All these functions and fixtures can be well executed using a customized sequence to achieve multiple objectives within a short time period. Please do not hesitate to contact us if you have any questions, or you can check out the website listed above. Thank you so much for your time and attention.